Okay, hope everybody else had a nice afternoon tea. Thank you for coming back. Up now, we have Edwin Griffin, who's a senior secondary teacher at Gungahlin College, and a number of his students, as he will be presenting on student-directed projects.
Cool. Okay, it works. Awesome. Hi. So, yeah, I'm going to be talking about programming, Python, and student-directed projects. And this is a bit of a nebulous speech because there are going to be 4 of us talking at different points in time. So I figured I would just start by first having my slides work. Slides work now, please. Slides work. Oh. Excellent. Slides working. Cool. First, I figured I would just start by doing a quick overview on exactly how all of this is going to work, and then get into it. So. Basically, what I'm here today to do is to share some of the successes that we've had at Gungahlin College with IT education. Discuss sort of like the pedagogy of what we've been doing at Gungahlin College, so we can sort of hopefully explain where these successes have come from, and especially because it's PyCon, discuss the role Python has played in all of these things. So firstly, I'm going to be talking about all of that. Nextly, we're going to be having Hao Kim and Isaac McClure, who will be talking about their project that they've completed, which is the automated Python-powered turret. And we're going to be concluding with Dion Missick talking about his project, Wordsmiths. And I will be going through exactly what those are a little bit later on. So, first up, I do kind of just want to give a quick overview of how the ACT system works and how we work at Gungahlin College, because there are a couple caveats to this that sort of help explain what's been going on. So firstly, we separate years 11 and 12 so that as a school, our entire cohort is made up of just year 11 and 12 students. And one of the advantages of this is we have a fairly significantly increased cohort size. So at Gungahlin College, our year 11 cohort is 600 students. Now, this is actually kind of cool because it means we get more opportunity to specialize, we get more opportunity to do really weird and different things because it becomes easier to maintain class numbers. We operate under the BSSS IT framework, which disappeared, there we go, which has around 21 units across a number of different course content areas. And these are the basic things like programming, robotics, game design, web design, and networking. As teachers, we pick and choose from this framework of 21 different semester-long units and basically just put together 4 for years 11 and 12. And that's how we design our courses. Now, what I'm going to be talking about here is specifically the programming stream, because this is kind of like how or where these guys are coming from. We start in year 11 with programming fundamentals. We assume no knowledge coming in. We start from complete baseline of programming. And the first semester is a basic introduction. So we look at variables, control structures, data structures, functions, those sorts of things. It's a fairly traditional introduction to programming. We follow this up with intermediate programming. This is second semester, year 11. This is where we look at object-oriented programming. This is where we look at some event-driven stuff. This is where we look at objects, classes, relationships. We start introducing more complex concepts like polymorphism. And we do some of the stuff that lets them put together larger projects. In year 12, we then hit advanced programming. And advanced programming is when we get to start looking at some really cool stuff. This course is focused on computer science concepts. We look at recursion, we look at regex, we look at time complexity, we look at probability and combinatorics, we look at trees and different kinds of data structures, more stuff than they've sort of ever been exposed to. And the cool thing about this is we get to look at this, or at least the way we've designed this is we look at this in a way that you traditionally wouldn't see outside of a tertiary or university context. And we get to look at that in some kind of meaningful or useful way. So, in this course, students are introduced to each of these sorts of computer science-y topics, and then they choose one that they like to investigate. And they spend 3 weeks doing this investigation and producing a research paper looking at this topic. After that, students then develop an application based on that research so that they can do something cool with the stuff that they thought was cool. That's kind of the underlying approach here, is just pick a cool thing and do a cool thing. So, sorry, there was one thing I forgot to mention. With advanced programming, we did run into a bit of a problem when we were first designing all of this, because when you've done programming for a year already, it's hard to find those kinds of students who want to advance even further and extend themselves even further, because it's really, really difficult when this is the very first entry point for IT, and you're sort of exposed to all this kind of stuff. Usually we would only get somewhere between 2 and 4 students in an entire cohort that would actually be interested in doing this, and it was really hard to justify an entire class of only 2 to 4 students, so it didn't really happen very often. So we needed to figure out a way to get around this, and we did. We came up with a sort of traditionally ad hoc and then slowly built up approach to teaching to help solve this problem. So we run our classes similar to an online course. All the material is made available online, and the students are expected to work through it, or sorry, they're allowed to access all of that material and work through it at their own pace. We maintain a weekly requirement, weekly deadlines to make sure the students stay on track, but the students are basically given the week to say, get to this point by the end of the week, here's all the resources you need, here's where you can get help. And this is what it ends up looking like. This is Schoology, our learning management system. And basically, on the page, you would access this. You would see all of the courses available to you. Each course has a week-by-week breakdown or a topic-by-topic breakdown, depending on who's actually teaching the course. And then all the content is just available to you. And you work through this. It's scaffolded. It's timelined to help you get through all of it. So typically, students would taste a different number of the courses, see which ones they like, stick with that one over the semester, and then just power through the content. Now, in addition to this, classes are still held like regular classes, so we still have our standard 4 hours a week of school. But these classes are different. They're not traditional sort of directed instruction classrooms. They're much more like tutorials. This is akin in flipped teaching in that regard, because the students will develop their knowledge, develop their understanding on their own. They will research this material and then figure it out, and have to have figured that out, excuse me, so that by the time they get to the classroom, they come to you with the problems that they've run into. And they go, I was doing this at home, and I got to this point, and I had no idea what to do. Please, please help me. And so they come into the classroom, come to these tutorial-style sessions, and they get help with whatever they've been running into. I found this has really helped shake up the classroom dynamic, so that the students will show up to class with a problem that they want solved. And they will come in, and not always enthusiastically, sometimes quite frustratingly, but they will come in and come to you and say, I have this problem, I need this solved, how do I do it? And I find this quite different from students coming into the classroom, sitting down and going, teach me. Because it's coming from them now. Assessing this, not necessarily discussing this from a formal assessment standpoint, but from an informal assessment standpoint, we have a number of systems used to monitor student progress. So like I said before, we use a learning management system to track their weekly submissions. And we use Schoology, but any learning management system that can track weekly submissions would be fine. So something like Google Classrooms would just equally work as well. But one of the key things here is our automated feedback systems. And when I say our, I mean Groks. So we've been making use of Grok for quite a long time now. And systems like Grok, systems like the interactive Python textbook, basically things that have an automated marking system built into them, things that have good feedback systems built into them, things that allow students to get constructive feedback on their successes, constructive feedback on their failures, so that they can get into a habit of reinforcing and building themselves up without teacher intervention. And then when they get to the point where they are super frustrated, where they cannot progress any further, they rock up to one of the tutorials and they get their teacher help, and we push them through it. So the net result of all of these systems is that students have ended up becoming more self-directed. And they become more and more capable of solving those problems, troubleshooting those progress blockers that they would usually slam into and then just collapse in a giant heap. And I've found that through this process, yeah, they're able to figure out how to get around that. Python has played a somewhat critical role in actually assisting with all of this. So it was chosen fairly early on that Python was going to be the first language we would introduce. We do discuss some C++ and some Arduino to give them a taste of the world, but Python is the first language to introduce, and there are a couple of reasons why we do that. One of the, to be honest, most of these reasons are going to be things you are all quite familiar with. Python is cross-platform. It's lightweight. We're a BYOD school. We weren't always a BYOD school. And being able to say, we need this thing deployed usually took somewhere between 3 and 6 months. So being able to say, we would like Python deployed and then having it deployed and then not having to worry about getting other kinds of things deployed to help it along was really, really useful. It is clean. Its syntax is clean. Its syntax is readable. When students read it, they understand that it looks like words. It's not confusing and strange and scary. You have access to some incredible libraries that help you do some really, really powerful things. And my students today are going to be showing you exactly what those things can pull off. There are a ton of online resources to allow you to teach Python and allow you to learn Python, so it's easy to sort of help troubleshoot those problems. And the community is active, engaging, and probably one of the better communities that I've seen in terms of if I need help with something, I can just get help with something. All of these things together gives the power to really extend the students and really get them to do some absolutely cool things. So, one of the things we try to encourage, and one of the reasons we're here today is this whole collaboration and industry engagement thing. We get in different industry mentors from our local region, from different academic institutions to come in and do workshops with the kids to really sort of like get them to understand that this is a real world thing. What they're doing actually has meaning and purpose. The students are then required to report back on that and actually discuss like what they've achieved. And this is to local schools as well as to local industry. We try to take part in as many competitions as possible. We take part in things like YICTI because, again, it's more just about exposure and getting students to sort of comprehend and understand this is the world and this is how this all works. And we take part this year in PyCon. Which was a very hastily taken photo earlier this morning. But the idea is to make these things more than just assignments, to make these things projects that they want to do. So all of these projects, or the projects that I'll be showing to you today, were born from an investigation in advanced programming that I discussed before. So without thinking about a practical project itself, they picked a computer science topic and then ran with that topic. So Hyle and Isaac picked computer vision. That's what they thought was cool, and that's what they wanted to investigate. And this ended up with a Python-powered turret, because shooting things is cool. Dion basically came to me one day and said, how does Google Docs work? And then after some rapid Googling, we discovered Google Docs works through this magical thing called operational transformation, which he decided to investigate and start looking at. And the result of that is his project, which is called Wordsmiths, and I'll be happy to talk to you about that as well. But I have been talking for 12 minutes now, so I figured the easiest way to get you guys to understand exactly how this works is if the kids come up and do it themselves. So, Isaac, take it away.
Hello, I'm Isaac, and I'll introduce me and Hale's project here. So me and Hale, our project is a Nerf gun, which is mounted on a servo motor, and it uses 2 cameras to identify people and their ranges using openCV libraries. And yeah, well, we kind of chose this because, as Edwin said, we got interested in computer vision and we like shooting stuff. So yeah, it just seemed pretty obvious to put the 2 together, and yeah, that's how we got it. And when we pitched it to Edwin, I got to give him a hand because it was very encouraging, and he, you know, was very enthusiastic about it. Making the project was much easier said than done, and it's taken a lot of time to get to where it is now. Even now, there's some improvements we'd like to make, but we're pretty happy just to have it in a working state. Yeah. So the project had many aspects, both physical and software related. Our greatest challenge was probably with the software and debugging, as I'm sure all of you have experienced a lot. But we also experienced some issues trying to get the pieces of the project to come together. Python definitely smoothed the process of putting it all together by making it so easy to install and use libraries without having dependency issues that you might get elsewhere. Now we're really quickly going to run through how it works on a more technical level, but if you would like a very in-depth presentation, make sure to come to Hyle and my presentation in the main conference tomorrow. So we were using hog feature detection to find people. Feature detection is essentially the art of finding the important or distinctive parts of a pictured object. But to do it well, some things have to be taken into account. Speed and the ability of the descriptor to discard noise, and also be able to detect the same feature in a similar fashion when lighting, scale rotation, or even to some degree viewpoint changes between images. These are the sort of things you look at when choosing a better descriptor. The detection we used is named by its method of doing this. and describing areas using a histogram of oriented gradients. We create that description of an area by first going to each pixel in an image and applying a kernel or a mask to it, and creating a horizontal and vertical value of gradient for each pixel. Once we've done that, we can use those two values to create gradient orientation and magnitude. And then once this has been done for all the pixels in an area, we can create a histogram with it, which is basically just a graph. We then normalize the histogram to discard the noise that would be created by changing the intensity of the light that was hitting it. Yeah, so after we've done that, we basically pass this to a support vector machine classifier, which attempts to classify whether or not you have a human or not a human. And hopefully you get something like that. Now, yeah, I'll give you to Hyle, and he'll talk you through the rest of it.
Good afternoon. So, in our project, the hawk detector finds pedestrians, which are essentially our targets to shoot at. Now the turret needs to determine how far these targets are in order to shoot the closest target. Since a regular computer with a single camera isn't able to do that, we're using two cameras. This technique of finding depth is called computer stereo vision. Essentially, two cameras are able to create depth perception because an object appears at different locations in the images taken by those two cameras due to the distance in between. This is also how our eyes create depth perception. Looking at an object with one eye will be different when looking at it with the other eye. According to computer vision terminology, this difference is called disparity. The disparity is bigger when the object is closer to the cameras and smaller when it's further. This creates depth perception, allowing the computer to see distance. This is a simple example of disparity. The red dot represents a 3D point, and the squares represent two images taken from those two cameras in distance. Even though this point is stationary, it shifts between these images due to the distance between the cameras. We have decided how the turret will see distance. Now the same 3D object has to be found on both images. This is where feature detection and matching algorithms are used. Fortunately, openCV library includes those. In our project, I have used oriented fast and rotated brief for feature detection and brute force matcher for matching those features. Firstly, I found all the features on both images using the orb detector, and then I matched them with the BF matcher. Then I used the disparities of those points within the targets boxes that we got from the hawk detector earlier to calculate distances to them. That allows the turret to find and shoot the closest target. In our project, the use of Python helped us. Libraries such as openCV and NumPy were available on Python, and they're very easy to find and install. openCV library included feature detecting and matching algorithms, so we didn't have to reinvent those from scratch. NumPy library helped us on processing images, since openCV uses NumPy arrays to represent images. The simplicity of Python was a big factor as well, since its high readability allowed us to code and debug without much difficulty. Using openCV, NumPy, and Python, I can create an empty image and display with just 2 lines of Python code shown in the first snippet, and reading an attached camera and displaying a real-time video is as simple as the second snippet. The open-ended choose your own adventure type of project was at first very intimidating. It took us a long time to narrow down what we wanted to do relate to computer vision. After that, a turret immediately seemed like a fun option to us. Because the project allowed us to do something fun, we worked much harder to understand and implement difficult concepts. This can, of course, go both ways. But for us, it has allowed us to push into new areas that our education would have only touched on briefly otherwise. The opportunity to do that is something that we're very grateful for. Now I'll pass on to Dion.
Hello, everyone. As you said, I'm Dion Missick, and this is my project, Wordsmiths. My project studied the algorithm known as operational transformation, which is something that Google Docs uses to allow users to share over a document. When I started to look into this with Edwin, when we first Googled what it was pretty daunting because a lot of the stuff we found was behind academic papers or corporate walls. And that leads me to the purpose of what I'm trying to do with the project. I made the project open source because I want people to figure out the algorithm from an easier standpoint. I don't want them to go through the same sort of troubles that we went through when we were trying to install it. Like when I was trying to figure it out and I started to study it, there wasn't a simple guide or a place where the algorithm was located. So I've open sourced the project under the MIT license so other people can improve and work on the project. It's available for installation over pip as well. So the role of the algorithm is to keep 2 or more users in sync on one document in real time. Most people think if you just give a connection to two users and you just let them edit freely, that they'll be able to edit like you would in Google Docs. And that's initially what I thought would happen. I'll show you visually why this isn't the case. Imagine a world where 2 users are on the same document without any algorithm in place to keep them in check. Users in this world can insert or delete characters, which are applied locally and then sent to the server. Imagine the document starts with the characters A, B, and C, like above there, at the position 0, 1, and 2 respectively. User 1 tries to insert the characters XX at position 1, and user 2 tries to insert YY at position 3. You'll see quickly when the operations get sent to the server and to the other user, both strings end up at a different place. They become unsynchronized. This is the issue which occurs and what operational transformation is made to solve. Here is the same example we saw earlier, where there's a document state of ABC, and the users are trying to insert the same characters. So operation 1 on the left side of the screen is essentially the first user trying to insert the characters XX at position 1, and then operation 2 is user 2 trying to insert the characters YY at position 2. You'll see that with the algorithm, they end up in a state where they are synchronized rather than unsynchronized. And that's pretty much my demo. Python's impact on my project was quite significant. It was easy to document because it's such an easy to read language, making it simple by nature. So we don't have to go very in-depth in documentation for it because it's just so easy to read. Using Python also made it easy to rapidly develop web applications because I can install libraries such as Flask and Socket.io, which makes managing complex web protocols like WebSockets a lot easier. I also thought it would be worth mentioning that the user-friendly data structures that Python gives makes it a lot easier for me to understand and implement this project because a lot of the project involves moving around data in real time. In an educational standpoint, this project has allowed me to go from a point where I knew nothing about the web or any complex algorithms or any of that, starting with learning programming last year, to a point where I can rapidly develop web applications and even implement complex HTTP and WebSocket protocols. It allowed me to understand how algorithms work and the process behind researching, analyzing, and implementing them myself. I learned how to deploy web applications to a web server using a virtual private server. More technically, I learned how to use a basic deployment stack with Nginx as a reverse proxy and load balancer, and Gungahlin to run an eventlet server with multiple workers. The future aspirations of the project is pretty much to end up in a point where I have an active open source repository. I want a place where operational transformation can be discussed, improved upon, learned about, rather than hidden behind walls and Google. I know when I was developing it, I really wanted something that I could just plug into my project and study, because it was quite difficult to understand from, oh, Google does this. It should be documented pretty heavily, to a point where I was pretty disappointed. I couldn't find anything. So I want to get my position as an open source library to a point where people can do that and they can learn from it. Also, as a side note, I'll be presenting a more comprehensive talk tomorrow at the PyCon general sessions at 2:15, if anyone wants to come to that. And then I'll give it back to Edwin for questions.
sure. Yeah, I mean, like, yeah. Questions would be good.
If anyone has questions.
I mean, you guys can answer the questions too. You don't need to. Like.
So my little brother is in year 11 at the moment. Comes home with IT work, and it's quite frankly, it's depressing. So I'm just wondering, what is it that enables you guys to actually do justice to a tech-focused curriculum?
Accommodating heads of department is a good start. That let me basically say, hey, this is a cool idea. Please let me do this cool idea. And they say, sure, whatever, go for it. Basically, access to resources. I started running this whole, well, not running, but I started as part of this whole IT doing new stuff venture with having never looked at Python before. And my prep for entirely teaching a new group of guys Python was Grok. I basically did the Intro to Programming 1 and Intro to Programming 2 on Grok and said that was really, really cool. And then delivered that to my students. And then one day, my students came to me and said, this is a cool idea, how do we do that? And I said, I have no clue, let's Google it. And basically, yeah, I found that being really open with the fact that my students will surpass me in knowledge quite rapidly, and being willing to just sit with them and go, if I don't know how to do something, I Google it and then figure out how to do something, or at least I figure out what I need to do at that exact time that I need to do it. Showing them how to do that so that they can get to the point where they can do cool stuff. They might not know exactly how all of the cool stuff works, but they can do cool stuff, and that energizes them and invigorates them. And then, yeah, just letting them do that over and over again until they understand everything, or everything they want to.
Hi. I understand that the projects were done over 3 weeks. I'd just be interested to hear from the students how much time they put into those projects.
Too much. Yeah, there was a lot of late nights. I think you would have seen one of the photos there. I looked basically like a zombie. I think it was because it was probably 2 a.m. and it was the first time I managed to get the damn thing to work. So.
In terms of officially, we have 4 hours worth of class a week, 4 hours expected study outside of class a week, so 8 hours per week themselves. And then on top of that, because we run our classrooms like tutorial style sessions, a teacher is just in the classroom at any point in time. So if they need help, they come in and get it. And so these guys specifically would generally spend all of their free time in my classroom. Because there were a lot of times when they would freak out and need help, and then I would just look at it and go, I don't know. Let's Google that, and sort of solve the problems that way. But yes, I would imagine many hours were crammed into those 3 weeks.
This is for the boys. I teach senior students, and getting them to take big risks and do stuff that's scary and hard is really, really difficult. What made you confident enough to do something that you had no idea how to do and just wanted to solve an interesting problem?
It was mostly because me and Isaac picked really interesting topics like making a turret and shooting people. That's really good. Also, we really just get a lot of help from the teachers when we need to. So I guess that's how we did it.
You don't get that much help.
Well, I don't really have like an answer as to like what motivates us, but it's sort of, we have to study an algorithm. We're going to want to find something that we want to spend the whole year working on, or however long we've been given to be working on. We don't want to be working on something that doesn't look cool or doesn't excite us. And I guess they make it clear to us that you want to be able to enjoy it while you're working on it. And so I guess that's why we look for something interesting. I think less about marks, more about what I think will be cool to create. And I feel like that's with most of us in the class.
Any further questions?
Just a quick question about the Nerf gun. How did you interface Python with your Arduino?
Apparently it doesn't want to at all.
We used the serial port. Sorry? with PySerial. Yep.
I wanted to comment on something that I heard from a lady in the front. Sorry that I don't know your name, but it's with regards to the like being bold enough to have come up with such, great projects for the learners. And I think that mainly it's not about how bold they are or how bold the teacher is. It's mainly the teacher giving them confidence, because at all times the learners are going to be afraid. They won't know what's ahead. So if the teacher is able to expose them as much as I can, maybe take them to conferences like this, just so that they know, what's out there, because they won't know what's out there until they're exposed. And then you just starting, because if you start teaching them programming, for example, later on they start coming up with the ideas, and eventually they will be confident enough to have, great projects. So mainly it's just introducing them and keeping them interested and keeping them learning, and then eventually they will come up with great project ideas like they have.
That's all we have time for. So thank you, Edwin. Thank you, boys.
Thank you very much.